So I'm going to show a simple example of when you might want to use integration by parts twice to get the solution to one particular integral. So first of all, we'll remind ourselves of the integration by parts formula. So the integral of u dv by dx equals uv minus the integral of v du by dx. And the example that I'm going to look at is we're going to try and integrate x squared e to the x. Now the first thing we need to do is decide what we're going to have as u and what we're going to have as dv by dx. And I'm going to choose u to be x squared and dv by dx to be e to the x. And the reason for that is that if u is x squared, when I differentiate it, I'm going to get 2x. So du by dx is going to be 2x, and it's getting simpler. If I did it the other way round and chose u to be e to the x and dv by dx to be x squared, then when I integrate dv by dx, x squared, I'm going to get x cubed, or a third x cubed. So my v is going to be a third x cubed, which is going to be more complicated. So it's better to choose u to be x squared and dv by dx to be e to the x. So I'm just going to write that down here. U equals x squared, dv by dx is e to the x. So du by dx is going to be 2x, and v is going to be e to the x. And then I'm just going to substitute those values into my integration by parts formula. So I'm then going to get that the integral of x squared e to the x. So it's u times v, so that's x squared times e to the x, minus the integral of v du by dx. So that's, again, e to the x, du by dx is 2x, so it's minus 2x e to the x. And now I need to integrate another product. I've got x e to the x. So I'm going to use integration by parts again to integrate this. And in a similar way, I'm now going to choose u to be x, and I'm going to have dv by dx equals e to the x. And the reason for choosing them this way round is that when I differentiate u, it's going to just get to 1, so it's going to get simpler. If I did it the other way round, I would then be, if I said that dv by dx was x, then v is going to be a half x squared, so it's getting more complicated. So it's better to do it this way round. Du by dx is 1, v is again e to the x. Remember that these are different u's and v's from the ones I used previously. I'm just using the formula again and choosing my variables to integrate this integral by parts. So now on my original question, I'm going to have x squared e to the x minus, then I've got 2, and now I want the integral of x e to the x. So let's put some brackets there, and it's going to be, so I've got u dv by dx integrated is u times v, so that's x e to the x, minus the integral of v du by dx, that's e to the x times 1, so that's just e to the x. And I probably should put plus c for my constant of integration. I don't know whether we can simplify this much more. I think I can say that that's x squared minus 2x plus 2 times e to the x plus c. So there we have it. We've used integration by parts twice. We used it once to break down our x squared e to the x integral, and that gave me an x e to the x, and then I used it again to break down the x e to the x integral, and that gave me the answer that I wanted. So thanks for watching.